equation that says a sub n is equal to 67 plus n minus 1 times negative 6. And right there is the general equation, the nth term equation. Any questions so far? This is a very classic style problem. You will see a problem like this on the test. So the last part is to find u sub 34. So all we have to do is say, okay, a sub 34 is equal to 67 plus 34 minus 1 times negative 6. Oh. That's the nth term equation. So the general term is the nth term. So 67 plus, what is that, 33 times negative 6? Negative 131. A sub 34 equals negative 131. Right there. Anything else out there? No? All right. All right, let's move on to number 9 now. Number 9 goes like this. Find the sum of the arithmetic series. And here is my series. 3, 7, 11, 15, all the way to 20 terms. So let's fill in, let's write the equation that tells me the sum of an arithmetic series. What's the equation for the sum of an arithmetic series? Is that correct? Yes. All right. Do I know what n is? Yes. What is it? 20. N is equal to 20. How do I know? Because it says 20. Yeah, it says you want to add up the first 20 terms. Do I know what a sub 1 is? It's 3. Do I know what a sub n is? No, I don't know what a sub 20 is. Can I figure it out? I do believe. So let's write the nth term equation. A sub n is equal to let's try and figure out a sub n real quick here. For those of you that don't see the connection to the second term, to the second equation rather. A sub n is equal to 3 plus n minus 1 times, what's my common difference here? Yeah, if I take 7 minus 3, I get 4. I take 11 minus 7, I get 4. I take 15 minus 11, I get 4. Obviously tells me that D, the common difference, is equal to 4. So D is equal to 4. Plug in 4 right here. Now I'm looking for the 20th term, so A sub 20 is equal to 3 plus 20 minus 1 times 4, which should be A sub 20 is equal to 3 plus 19 times 4, which should be 76. Yep. You could also use the second equation. Plus 76. So A sub 20 is equal to 79. So now I know that A sub n over here, when n is 20, A sub n is equal to 79. Have I lost anybody yet? Is anybody out there confused about anything that I just did? What's that? That's not the sum yet. But we're ready to find the sum now. Because now all I have to do is plug it into this equation here. So, I know that S sub 20, the sum of the first 20 terms, is equal to 20 times 3 plus 79 divided by 2. S sub 20 is equal to 20 times 82 divided by 2, which is S sub 20 is equal to 820, right there. And that takes care of that first one there. The second one, part B, is very similar to part A, but I do want to move on to another one so that we can see how to do a finite geometric and an infinite geometric. These are a little bit trickier. So, number 10, find the sum of the geometric series here. We're going to find the sum of this geometric series right here. All right, well, let's see if we can find the equation for the sum of the geometric series. How do I add up a geometric series? You gave it to me a few minutes ago. That's it right there for a finite geometric sequence, right? That's how you add up the terms of a finite geometric sequence. So let's take this right here and let's figure out what we know about our sequence. Do we know what n is? How many terms are we trying to add up?
Wait, which one are we doing? 10.
So n is equal to 10. Do I know what a sub 1 is?
Yeah.
What? It's 12. Do I know what r is? We don't know it yet, but we can figure it out, right? Let's look at our sequence. Remember that for a geometric sequence, r is equal to a sub n divided by a sub n minus 1. So that means r is equal to any term, 6, divided by the term that came before it, 12. So r equals 1/2. Now we know all the bits and pieces that we need to know. So the sum of the first 10 terms here, the sum of those first 10 terms is equal to 12 times 1 minus 1/2 raised to the 10th power divided by 1 minus 1/2. And this is definitely a handy-dandy calculating device type problem. So we do 12 times 1 minus 12 times 1 minus 1/2 raised to the 10th power, close that, equals divided by 1 minus 1/2 is the sum of those first 10 terms, 23.97, right there.
Is there any specific way to put the actual sum in summation notation?
Nah, it's just, summation notation just tells you how to make the sum.
Okay.
This is just, once you figure out the numbers, you're done. All right. So the last one I'll do here is the sum of the infinite geometric series. Now, this is the last equation that you'll have to use on the test, and that's the sum of an infinite geometric sequence, and that looks like the sum of an infinite sequence is equal to a sub 1 divided by 1 minus r. And only works only if the absolute value of r is less than 1. All right. Find the sum. Find the sum of the following infinite geometric series. So, what is my R here? R is equal to a sub n divided by a sub n minus 1. So, pick any term. Let's do negative 12 divided by 18. R is equal to negative 2/3, right? And if I double check, I want to be absolutely positive, I can do R is equal to 8 divided by negative 12, and oh my word, look at that, what do you know? Negative 2/3 again. So it all works out very nicely for us. So we know that R is equal to negative 2/3. Do we know what a sub 1 is? 18. So all we have to do is say, okay, the sum of that infinite sequence is going to be 18 divided by 1 minus negative 2/3. So 18 divided by 1 minus negative 2/3. I'm good. 10.8. Hey-o. So the sum of that infinite sequence is 10.8. Right there. Let's get that. There we go. 10.8. Are there any questions on that particular problem? No? All right.
Number 12, are you just asking us to use summation?
Yep, I'm asking you to use summation notation. That's exactly what I was talking to Manuel about when I wrote that up. So when you write that summation notation, all you have to do is write the sum, and then in here, your nth term equation goes. And you put n equals your starting point, usually 1 or 0, and up here is your ending point. You could use n, or you could use a final term. For this one here, yeah, for n terms, that means that you would start at 1 and you would end at n up in the top. So just to give you number 12 here, we have just a few seconds. Well, let's see. Let's see that very first one, right? This one is 4 to 11 to 18, so that's adding 7 every time. So that's an arithmetic one. So all we have to do is write out the nth term equation. So a sub n is equal to 4 plus n minus 1 times 7. And then we can say that, okay, all I'm going to do is I'm going to go, here's my summation notation, and I'm going to go from n equals 1 all the way to n. And I'm going to say 4 plus n minus 1 times 7. And that's all there is to it. Sometimes you might see this written as a k here, so you may also write it like this. K equals 1 all the way to n, 4 plus k minus 1 times 7. But I'm not going to get too picky about either of these two answers. I will accept either one. All you do is put the nth term equation right in here, because all you're doing is adding up the nth term equations.
Would it be wrong if we put the a sub n equals? Would it be wrong?
Yes, yeah. You don't want to put a sub n here. You want to write the a sub n equation, but then just put the equals, the part that's on the right hand side in there.